Probability distribution. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. A probability distribution shows the likelihood of obtaining the possible values that a random variable can assume. By random variable, we mean a variable whose value is determined by the outcomes of a probability experiment, and the sum of its probabilities is 1. You can think of probability distribution as a way to show the frequency of each outcome of an event, and to help visualize a probability distribution, we can use a table or a bar graph. Let's see how it works. Two balls are drawn at random in succession with a replacement from a bag containing 4 red balls and 6 blue balls. Let the random variable x denote the number of red balls in the outcome. Construct a table and a bar graph to represent this probability distribution. The following table shows all the possible outcomes. Now, the probability of getting 2 red balls when we draw out the balls one at a time is. Likewise, the probability of red first followed by blue is. Similarly, for blue then red, finally, for 2 blue balls. Using the table found, we can construct the following graph. Let x be a random variable that represents the sum when 2 6-sided dice are rolled. Make a table. Draw a histogram showing the probability distribution for x and determine the most likely sum when rolling 2 6-sided dice. Make a table. The possible values of x are the integers from 2 to 12. The table shows how many outcomes of rolling 2 dice produce each value of x. Divide the number of outcomes for x by 36 to find the probability of x. Draw a histogram where the intervals are given by x and the frequencies are given by probability of x. The most likely sum when rolling 2 6-sided dice is the value of x for which the probability of x is greatest. This probability is greatest for x equals 7. So when rolling the 2 dice, the most likely sum is 7. A doctor estimates that his treatment of a particular illness is successful 60% of the time. He will treat 5 patients. Let the random variable x represent the number of successful obtained. Construct a table to represent this probability distribution. We are dealing with a binomial distribution because the number of observations or trials is fixed. Each observation or trial is independent. In other words, none of your trials has an effect on the probability of the next trial. The probability of success is exactly the same from one trial to another. The binomial distribution formula can calculate the probability of success for binomial distributions. The possible values of k are the integers from 0 to 5. Now we plug in the numbers to the formula and calculate the distribution. A survey has been done, and the result shows that 70% of people who purchase sports cars are men. Let the random variable x denote the number of sports cars owners men. If 4 sports car owners are randomly selected, construct a table of a bar graph to represent this probability distribution. We are again dealing with a binomial distribution. The probability of success is 70%, and the probability of failure is 30%. The possible values of k are the integers from 0 to 4. Now we plug in the numbers to the formula and calculate the distribution.